One, two, three. Assalamu alaikum warahmatullahi wabarakatuh. Good morning, grade 11. Good morning, Mom Simon. Today's report will be reported by me, Makhaell Deligos, and our lesson for today is discrete probability distribution. Now, before I start the lesson, let's do some warm up. So, I want you guys to tilt your head to the right first. 5 seconds. One, two, three, 4, 5. Next, 5 seconds in the left side. One, 2, 3, 4, 5. Next warm up is doing a 360-degree twist. Uh, do a circular do a circular motion. Do a circular motion for 5 seconds. One, 2, 3, 4, 5. Now next is arm twist. Well, I want you guys to do an arm twist starting from your right for 5 seconds also. One, two, three, 4, 5. Now the other one. One, two, three, 4, 5. Now for our lesson, our objectives is illustrate the mean, the variance of discrete probability distribution, calculate the mean and the variance of the discrete probability distribution, to find the standard deviation and the coefficient of variation. Now, we are in this lesson, we are supposed to get the mean, which is kind of like a U shape, and we're supposed to get the variance. Now, what is a discrete probability distribution? Discrete probability distribution counts occurrences that have been countable or finite outcomes. It is in contrast to a continuous distribution where outcomes can fall anywhere on a continuum. Example 1. A laboratory supervisor in hospital is investigating number of reported on the job training accidents over a period of 1 month. Based on the past record, she has derived the following probability distribution for X, where X is the number of the reported accidents per month. Find the mean. Now, here is the table. As you can see, the table is right here. Um, the table is right here, and the probability is P open parenthesis X. And in order to get to calculate the population mean, we need to it's as simple as times we need to times the zero to the accident report and the probability. We're going to just times this. We're going to times it, and when we get the answer, it's zero. We gotta do the same thing on each of them, and once we get the answer, we're just going to plus it, and the answer we got after plussing the answers that we got from timesing all of this, um, that is the mean, and there is 0.95, nearly one accident reported in the average month. So that's how we get the mean. That's how we get the mean. We just times the uh, accident reported and the probability open parenthesis x, and once we times it, the answers we get, we're going to plus it. We're going to plus the answers we get from timesing the what's inside the table, and getting getting the variance and standard deviation. Now, this example is we are basing this on the problem in example one, but this time we're trying to find the variance and the standard. Now, to determine the variance and the standard deviation, here is the formula to getting the variance and the standard deviation. Now, as you remember, in the other table, we have zero. Our x is 0, 1, 2, 3, 4. Same here, 1, 2, 3, 4. And now our px, which is here, Here's our px. We are going to put it here in the table, and then we're going to total it. So we get a total of 1.00. And next is we're going to times it. So our x is here, and then we're going to times it with the px, which is our x is here, and we're going to times it with the px. We just need to follow the formula. All the in this lesson we just need the important of formula is really needed in this lesson. Without it, we won't able to solve the mean and the variance. Now once we times this one, this x times px. Once we times this, the answer that we get will go here, over here. This is the answers we get. Now then we're going to total it again. Here we don't need to total. We just don't need to total here. Here we're going to square root. No, we're going to square. We're going to square the answers we got here. So 0 squared equals 0. 0.25 equals 1. 0.2 squared equals 4. 0.3 squared equals 9. And 0.2 squared equals 16. We're just gonna square this, like we're gonna put square here, and once we get the answer, we'll put it here, over here. Now after that, it said here we're going to times the answers we got here with px, which is over here. We're going to times it. So x squared times p open parenthesis x. So 0 times 0.5 is equal to 0. 1 times 0.25 is equal to 0.25. 4 times 0.1 is equal to 0.4. 9 times 0.1 is equal to 0.9. And the last one is 16 times 0.05 equals 0.8. After timesing, we're going to add the answers we got here, which is 2.35, since we added everything here after adding. Now our variance, we in order to get our variance, we are going. This is the formula and how we're getting the variance. We're going to minus this over here. We're going to minus this, and once we minus that, it will be. If you can check in the calculator. Once we minus this, we get this 1.45, and that means we have 100. We have 1.45 accidents in a month. And in order to get our standard deviation, we are going to square root. We're just going to square root our variance, which is 1.45. We're going to square root our variance, which is 1.45, and then it will become 1.20. That's how we get our standard deviation. For variance, this is the way of getting it. But in standard deviation, we're just going to take the variance and we're going to square root the variance, and that is how we get the standard deviation, by square rooting our variance. Now, getting the mean, the variance, standard deviation, and the coefficient of variation, or CV, altogether. Now you might be thinking, what is coefficient variation? This coefficient variation is like the total, or the percentage of the total or the the percentage of variability of the mean. Now you might be thinking, what is this? I think you haven't taught us yet. I'll teach you the coefficient variation on on the examples that I'm gonna be showing you, because we can't get the coefficient of variation without getting the mean and the variance, same as the standard and deviation. We can't get those two if we haven't solved the mean and the variance. Okay, so here's an example. Also example 2. A rich investor was puzzled about two investment packages on which he is about to put in a large sum of money. He learned that two investments have the same average return investment, or ROI. The query is which is the best investment investment package. Now we're going to solve the mean, variance, standard, and deviation, and the coefficient variation all together this time. Now this is the table that is example table. We're going to base our we're going to base everything on this table, especially in getting the mean and the variance. Now, this is a way of getting the variance and the mean. Now here we are going just to times it. So x times px, which is for the package A. We're going for package A first. Package A, I mean, yeah. Package A. So our um, our first formula, we're going to times x times p into parentheses x, which is here 1 2 3 4 5 is our x, and our px is 0.2. We're going to times it, and the answers we get here, these are the answers. We're going to plus it. We're going to plus this. After plussing it, we get our mean. This will be, we will be able to get our mean after plussing this. And after we get our mean, which is 3 or 3.0, we're going to we're going to minus our mean with the x, which is this is our x over here. This is our x. This is our x. Okay, this is our x over here. We're going to times it. We're going to minus it with our mean. Our mean is 3. So once we get the answer, this is the answer we got after minusing the mean. We're going to, we're going to square root, no, we're going to square our answer here from this. We're going to square our answer from here. So negative 2 squared is equals to 4, negative 1 squared is equals to 1, 0 squared equals 0, 1 squared equals 1, 2 squared equals 4. Now after squaring this is the answer we're going to get. And we are going, it says in the other, it says here in the formula, we're going to times our answers here. We're going to times our answers here from our px. Our px is this 0.2 over here, 0.2 our px is 0.2. We're going to times our answers from here, from over here to our px. So 4 times 0.2 equals 0.8, 1 times 0.2 equals 0.2, 0 times 0.2 is 0, 1.0.2 equals 0.2, 4 times 0.2 equals 0.8. And that's how we get our mean. That's how we get our variance by after getting the answers from here. We're going to plus it. Also, we're going to plus it. Of this, we're going to plus this, and we are able to get our um, mean, our variance. Sorry, this is our variant. This is the sign of variant over here, and here is the sign of the mean. Now, for package B, same thing. We're going to do the same thing. We're going to same formula also. So we're going to times our 3, our we're going to times our x, which is here. Our x is over here. We're going to times it with 0.2, since this is our px. Same like the package A. This is the answer we get. We get 3 also. We'll do the same thing by timesing our x. We're gonna times our x with our mean. We're gonna times our x with our mean. So 3 minus 3, 0, 0, 0, 0. Just doing that. And the answers we got from here, we're gonna put it here, and then we're going to square it. After we get square it, after 0 squared is equal to 0 anyways. So really, there's nothing I didn't really put the answer here since it's really 0. And after that, we are going to get the answers we got here, which is 0, and times it with 0.2 or px, which our px is this. And that's how we get the variance for package. That's how we get the mean and the variance for package A and B. This is the variance of B, by the way, and this is the mean of package B. Now, in order for us to get the coefficient of the variation and the standard deviation, it's quite easy. This is a sign, by the way, of the standard variation, like the 2, but it's missing a square. Now, in order for us to get the standard deviation, like I said, in getting it, we are going just to square root our. We're gonna square root our. Um, we're going to square out our variance. We're going to square root this, like I said here, in getting the variance. We're going to square root our variance over here, and this is how we get our standard deviation, by square rooting the variance. Now, here we're just gonna square root. So our variance in package A is 2. We're gonna square root 2, which is square root of 2 is 2. And our package B, our variance is 0. Square root of 0 is 0. And we're going to get our population mean. Our population mean is for package A is 3. Same goes for package B. It's also 3. So we're going to put it here. And in getting the coefficient of variation, here's the formula. Over here is the formula in getting it. So CV, I'll just read the formula. CV equals the variance over mean times 100. Now here we'll put CV equals 2, since we are going to. Sorry. Don't mind this square. I made a mistake. We're going to times the standard deviation. So it will become um, CV equals standard deviation over mean times 100. Yeah, yeah. So what's gonna happen here is we're going to do the formula. So CV equals 2, which is our standard deviation, um, over 3, which is our mean, times 100 is 66.7%. And in package B, we're going to do the same thing. We're going to use the formula CV equals 0 over 3 times 100 equals 0. So that's how we get our percentage of the mean, or variability of the mean. And that's how we get the coefficient variation and the standard deviation. Without the mean and the variance, we are not able to get the standard deviation and the coefficient of variation. Now, there is some the formulas are different for getting the variance and the mean, right? It's different because here in the example one is just a normal way of getting the variance and the mean, just timesing it, then getting the answer, then tossing the answers, and that's how we get the mean. And the variance too, getting the just getting the variance and then square rooting the standard deviation. It has a simple way of getting standard variance and standard deviation and variance and the mean. It has its own simple formula. But since we are trying to get the coefficient of variation, it has to change in order for it to get the coefficient of variation. That's why our formula is different from the normal formulas in getting the variance and the mean, because we're aiming to get the coefficient deviation. Now here's another example. The CEO of the certain car manufacturer is confronted with a dilemma when the criteria set. Oh wait, sorry. Um, we got the query is which is the best investment. The best investment is using the interpretation of results. The average return of investment, or the ROI, are equal to 3 million for both packages. On the average, both are expected to deliver with the same benefit to the investor. Data are not the same. Yeah, it seems the data are really not the same when we get the variance of the mean. There are less variability in the package B than in package A. There is less variability on the package B than in the package A. The lesser the variability, the more consistent it is its average. Since both packages shall deliver in the same return of 3 million, it's better to invest. It's better to invest. Um, it's better to invest in the package B, as it ensures that every year the investor would get 3 million. So the best query in which is the best investment package is in package B. Okay. Best query for best to invest. Now here's an example, another example, example 3. The CEO of a certain car manufacturer is confronted with a dilemma when the criteria set for choosing the best car dealer of the year is based on the overall selling performance for the past 10 months. The table below shows the finalists in the said category. We're going to base it in the table, which is here. And this is the given table, dealer A and dealer B. Our X is here and our PX is here. Don't mind the Y. We're not really gonna use the Y. Yeah, we're not going to use the Y in the discrete probability distribution. Just the PX and the X. Here are the given numbers in the table. Oh, we're going to determine the mean and the variance of each distribution. First we're going to same thing. We're going to same thing as this, same thing as this, just the same thing. All of this. We're just gonna do the same thing over here. So I'll say it again so that you guys can understand. X times px, which is x times px over here. X times px. 25 in dealer A. Okay, we're talking about dealer A in the column dealer A. So 25 times 0.1. Let's see, 25 times 0.1 is equals to 2.5. Same thing we'll do here. 30 times 0.3 is equals to 9. 35 times 0.2 is equals to 7. 40 times 0.3 is equals to 12. 45 times 0.1 is equals to 4.5. This px is, we got it here, okay, over here. This is how we times it. And after that we're going to plus this again. We're going to plus this everything, and like, yeah, we're gonna plus everything here. The answers we're gonna plus, we get 35. But now this is our mean. This is our mean. Now it says here we're going to minus our x. Our x is this. We're going to minus our x with our mean. So, oh yeah, our x is here. Yeah, our x is here. We're going to minus it with our mean. So 25 minus 35, 30 minus 35, 35 minus 35, 45 minus 35, 45 minus 35. After minusing them, we get the answers. These are the answers of after minusing them. And we're gonna square root. Like I said, we're going to square root the answers we got here. So negative 10 square root equals 100, positive 100. Negative 5 squared. Sorry, we're going to square it pala. We're going to square. So negative 5 squared equals 25, positive 25. Negative 0 squared is equal to 0, positive 0. And the square root of 1.5 is equals to 25. Square root of 10 is equals to 100. And after getting the answers, this is the answers, we are slowly getting to our variance now. We're slowly getting our variance now. And what's gonna happen here is that we need the answer from here. We need the answers from here to times it with px. Our px is this. Oh no, sorry, our px is this over here. We're going to times it with the answers we got here. So 100.1 is equals to 10. 100 times 0.3 is equals to 7.5. 0 times 0.2 is equals to 0. 25 times 0.3 is equal to 7.5. 100 times 0.1 is equals to 100. And that's how we get our mean. I mean our variance. This is how we get our variance over here. After getting our variance, we are going to the next problem in getting the coefficient and the standard deviation. You guys can do this. You guys can not do this, but you guys can base it here. If you want to try, the one I teach you is just times and plus and minus thing here. You guys can try doing it by using your calculator. Check if everything is correct or not. But because everything that's gonna happen, everything that we did here we're going to do the same thing. After timesing, minusing, and then plusing. That's it. That's the only thing I think you need here. Square root, and that's it. Not that's not that complicated, I guess. Now, since we got our after getting our mean in dealer B, which is 36, and our variance, which is 74. After because we yeah okay. After getting the variance and the mean, we are going to square root 35, which is our variance. We're going to square root this. So the square root of the square root of 35 is 5.92. The square root of 74 is 8.6. And now we're gonna get our population mean. Our population mean is in dealer A is 35. And our population mean dealer B is 36 also. Oh no, 36. Sorry. Now we're going to do the same. We're going to do the formula to getting the coefficient variation. This is getting the coefficient of variation, which is CV times the standard deviation. No, CV equals standard deviation over mean times 100. So it will become CV equals 5.92 from the standard deviation over 35, which is the population mean, times 100 is equal to 16.1%. Now here CV equals 8.6, which is a standard deviation, over 36, which is our population mean, times 100 equals 23.9%. That's how we get our coefficient variation. So that means in our interpretation for this problem example, it's as is uh, what is the best category, or what's the best car dealer for the year based on the overall performance, which is the best. Now that means the best dealer for cars is the dealer B. It is much more variable than dealer A, since it's just dealer A is just 16.91%, and while the dealer B is 23.9%. Dealer B is 7 more variable than the dealer A. So that's how that's the dealer B is just the best car dealer of the year for selling performance for 10 months. Oh wait, I'm sorry. I mean, using the CV as a measure of the variability, it reveals the size of consistency relative to the size of mean in percentage. Therefore, the dealer A is the best dealer of the year. Yeah, since it's much lesser, which even that means if it's much lesser, it gets more. It has much average. It has bigger average. That means 16.91%. Dealer A was able to sell of cars. So he got 16.91%, meaning dealer A is the best dealer of the year. Yes. By the way, these examples are based on the book, which is in page 58. And before I end the lesson for today, I want you to do an activity for me. This For the following probability distribution, find the following based on your answer in the given table. The given table is over here. For A, you need to find the population mean, or U. I call this U because it looks like a U shape. Variance, standard deviation, and coefficient. We need to find in this A, B, and C, D. We need to find population mean, variance, standard deviation, and coefficient. Now here is the activity. Customer satisfaction rating on the service of the restaurant with 0 being the lowest and 3 being the highest. So in A we need to find population mean, and in B we need to find variance, and C we need to find standard deviation, and D we need to find coefficient. Using this table down here, we are going you guys are gonna base your answers on this table. After getting the answers, just write it, or if you guys want, you can send it to me in messenger if you guys are done. And here's another activity. Now, thank you for listening. I'll see you again. uh, Yun lang. Bye bye guys, ingat kayo, thank you for listening. Bye bye.